Welcome back to Advantest Talks Semi. Today we're thrilled to host the experts from Yole Group, the pioneers at the heart of the semiconductor market intelligence. Renowned for their meticulous research and profound insights, Yole Group not only tracks but also predicts the pulse of semiconductor test consumable markets. Today, from Yole Group, we're joined by Pierre Cambou. Pierre serves as the principal analyst for global semiconductors at Yole Group, with a rich background that includes founding a semiconductor startup and roles at notable companies like Thomson TCS and E2V Semiconductors. Pierre brings a wealth of industry knowledge. He is recognized as an expert in the semiconductor field, often cited by international media for his market and technology insights. Join Pierre and I as we delve into the latest developments in the semiconductor industry, where data meets strategy and future technologies come into focus. Welcome, Pierre, to Advantest Talks Semi.
Hello, Keith. Glad to be here.
So, on today's episode, what we'd like to do is really talk about the semiconductor industry, what's going on in the market, and in particular, what's going on in the mobile market. So you're from a company called Yole Group, which actually studies and provides reports on this. So how about we start with just a general overview of what you guys are seeing in the semiconductor industry?
Yeah, thank you, Keith. So the semiconductor industry is really, our main topic at Yole Group. So we cover this for 25 years. And it's not a very old industry. It's only 50 years that it really exists. And from the humble beginnings in some lab in the US, it grew quite significantly in the 80s, mostly in Japan with radios and VCRs. And more recently, it's really through the internet and mobile that the semiconductor industry grew to this 500 plus billion industry that we know today. This industry is growing really fast. I mean, it has the kind of growth rate that China is enjoying, 6 to 7% growth rates annually. And now we see some cycles. So sometimes it's 20%, like we enjoyed in 2021, and sometimes it's minus 10 or minus 8% exactly last year in 23. So yeah, there are ups and downs, but globally it's a fun ride.
Yeah, so it's very interesting how over the past 30, 40 years, the average is 6 to 7%, but like you said, we've had some extreme cycles with positive, double-digit positives of 20, sometimes even 30%, and conversely, we've had some deep declines also in the negatives, which are not the best years for the semiconductor industry. So, of the 500 or so billion of the semiconductor industry, about how much of that is the mobile market?
Mobile represent, so we consider mobile and consumer markets, which is 60%, and let's say 40% will be, 35 to 40% will be mobile. Another 15 will be personal computing and also consumer devices. So it's less than between 5 and 10. So it's basically the semiconductor industry relies heavily on mobile, especially in the last, let's say, 20 years, and even more since they are called smart. So our phone is really powering our lives, but also the semiconductor industry.
So you mentioned the last 20 years, which is interesting because that's actually when I came into the semiconductor industry, was in the early 90s. And then the mobile really took off sort of in the late 90s, and then in the 2000s, it was just on fire. And it's been an interesting ride to watch it progress from 2G to 3G to 4G to 5G. I don't know how many Gs we're going to have, but it had been growing. And I remember when we eventually got to 1 billion or over 1 billion phones per year, which is a phenomenal number. And now we've reached, I don't know, 1.2, 1.3 billion. You probably know better than I do. But for the past 2-3 years or so, we've been sort of sitting at that number. So could you sort of give us how you guys look at this market? What has happened to have it mature? And then what are we going to see, let's say, in the next 6 to 12 months?
Yeah, I mean, we should first decide what we want to look at. Is it feature phones, smartphones? So we made a clear distinction in the past. Now I think we should not anymore. So basically you have 1.2 billion, which is the smartphones, and you have an extra 400 million, which is the feature phone. So we are on the range of 1.6 billion phones being manufactured every year. The peak was around 2017 with a peak of 2 billion phones, whatever the kind, being manufactured. And then we came down to kind of the situation of today, 1.6, which is an extraordinary number, 1.6 billion phones. So we cannot, it's difficult to have more than one phone per inhabitant on the planet. And this is basically what we have. More or less, every 5 years now we are into a cycle of renewal. And so we know that we will have a peak of the average age of phones around 2.5, which means that by 5 years old phone are replaced every year.
In the last, let's say, since the AI boom has occurred over the last 2 or 3 years, now the AI chips are starting to be embedded into the phones, and it looks like that's going to have a positive impact or positive boost to the market in general. Can you say a few words on that?
I think this is the whole story of mobile. Mobile from the start revolutionized. Sorry for my English. Revolutionized the industry because of the addition from memory and compute that was the existing states of the semiconductor industry. We added all the analog RF chips, and then also all the autonomy, the battery powered aspects, and also all the sensors. So this is what we call the more and more. So when looking at the kind of chips that is inside the phone or powering the mobile industry, there is a diversity between memory, compute, and then also the more and more chips. So it's super diverse. And now we have the Gen AI that is invading the space. We saw Apple, for example, embedding neural engines a few years back. So this was a major event. And I think we are really on that trend when we want to embed even more AI capabilities on the edge. So yes, there is an ongoing technology shift within mobile, and it will drive sales. It's a renewal market, but there's always new things, new features to be added, and this is part of the game.
Yeah, agree. Want to go back to something you said a bit earlier, with about 1.2 billion being smartphones and around 400 million being the feature phones. I remember when that number was reversed, when most of the phones were feature phones and smartphones just sort of came into being, and then they were slowly increasing in volumes. So my question is, are the feature phones as a percent of the overall market, does that continue to reduce? and the smartphones is sort of taking over as just the de facto default? And then how does that play out in the different regions? So for example, in the US, smartphone feature phones versus India versus China.
It's an interesting story, and thank you for asking. There is almost no sales of feature phone or new in the US, but it's significant in India, yes, but very significant too in Europe, and especially in Germany. So there is a trend. And it's going down. We see the trend is going down, but not as fast as many have thought. So it's still. I think it has become a niche. Some people understand the value of this kind of phone. And do use it. I think we are also trying to mitigate our addictions to screens, and this can be the answer. So yeah, it has become a market that is interesting. It does not have much value. That's for our industry, because the average selling price of a feature phone is $50. When the average smartphone is about 500. So, okay, there's a 10 times ratio, so you can do the compute.
Do you have a theory or a reason behind why the feature phones are more popular in India and Europe versus they're basically non-existent in the US? What's driving that? Is it just cost?
Cost is part of the reason. I mentioned the idea that some people are fighting against invasions of screens, and they want to lower their screen time, and so they find a feature phone quite interesting to have. I also think there is a kind of a culture and a status symbol. In some societies like the US, it's very difficult to go by your everyday routine without a smartphone. Otherwise, you are completely you could be quickly in trouble if you don't have a smartphone. And I think in China, it's probably the same now. In some places, I know in Europe, you can still go by with only a feature phone. So, it's interesting to notice this, and there is a significant number of. I say it's cheap, but there's a significant number of components like cameras that are already on those phones. So it's good to know that it still exists. And as the Southeast Asia countries also rise in purchasing power, we know those markets for feature phone will maintain in the future. If I would like to make another parallel, maybe with the feature phones, it's with automotive. We were asked recently, one of our customer, what was ADAS level 0. So I believe you know ADAS, advanced features for cars. Is there any market for no ADAS level 0? Yes, there will be, probably similarly to phones, to feature phones. So maybe 10% of the market will maintain without any electronics, and mobile is the same.
That's interesting. I hadn't thought of that. So where would that 10% be geographically?
Again, it's not just a geography. The key learning we have right now is it's a niche market. It is a niche market. So even with advanced countries like Germany, you will or Europe at large, you will find customers that want to stay clear from smartphones, or in some occasion they want to have a very simple phone to be for their kids, and they don't want an access to screen, and so they will acquire this very simple phone. So it's really pure marketing here. There is an application case, let's say, for feature phone. This application case does exist even in a mature market like Europe. I don't know about China and the US because those markets are very different. But and also on emerging markets like India, it's very popular because it has to be very rugged in some places. I've seen places in Africa, people having those feature phones. You need very rugged handsets so that it works on very little power, for example. So it's very interesting.
Yeah, it's hard to imagine anyone without a phone these days. So I want to go back to what's going on with AI and edge technologies like smartphones. So given this, let's say, new feature, like you said, AI invading the smartphones, does Yole look at how that will affect the forecast of smartphone production in the future? So like I said, right now, and you said we're at 1.2 billion-ish smartphones. Do you foresee that AI is really going to drive that or change that appreciably, or is it going to stay about the same?
So I think the market is really has been maturing. What we've seen, we've seen the penetration of the number of devices per inhabitant on the planet, where reached kind of a limit where almost everyone on the planet has a phone now. And basically during the COVID-19 episode, so 21, 22, there was kind of a bubble. People had some extra money, especially in the US, Europe, also China. They stay at home, so instead of enjoying, trips abroad or a vacation, they had to stay home, and they had some extra money on mobile and consumer products. So we saw the bump, extra and the decrease in 23. But overall, what we measure right now is that we are back on the previous trend of it's a slow growth, in line with GDP growth, basically. GDP growth is 3% a year. So this is our expectation. For sure, there is a requirement to attract customers with new features. So, such as embedded AI is one of those features, and so it will drive the growth of mobile in the next 5 years.
Also, if you could talk a little bit about Rapidus, I think the audience would really appreciate that.
Yeah, so what we did is to cover the Foundry capacity worldwide, trying to understand was it a push or a pull. We know there is a lot of government incentives with chip acts in Europe, in the US, but also in Japan. I think there was a lot of desire to reshore some of the capacity, such as the TSMC, Sony joint venture in Kumamoto. So that was super interesting. And yes, this Rapidus, the creation of Rapidus, and from our understanding, I didn't know how strong was Japan. We saw the collapse of some of the big names like Toshiba, and the creation and the restructuration of the Japanese ecosystem. And really, what we saw today is kind of a ranking today of the different foundry capacities. Taiwan and Korea being first for sure, but Japan is just behind, and this was kind of a surprise. A lot of the American capacity, America boasts about 10% capacity in the US, and controls about 10%, but abroad. Like we know there are foundries from Micron and in Taiwan and in Japan. So this kind of capacity is US owned, but is really locally, geographically located in Japan, Taiwan, or China. So Japan has a strong position today, and is expected to have even stronger through this effort that we see today. And they were the quickest to have fabs online. So we saw in 2 years just TSMC being able to brought online their fab in Kumamoto. And so Rapidus, if I had a few bucks to bet on Rapidus, maybe I would do that.
So yeah, it's interesting. Normally when we bring a fab online, or when anyone brings a fab online, it takes, 3 to 5 years before it's really up and running. And like you said, it's a testament to Japan that they've been able to, and TSMC, that they've been able to just bring that online in 2 years. And anecdotally, so Advantest is a Japanese-based company. Our headquarters is in Tokyo. And I know a lot of employees that have recently joined Advantest, specifically for some of the reasons that you've outlined, that they're now, let's say, older in their careers, and they want to revitalize the industry for their home countries, or for their home country. So I see that not just at the global scale, but even at this micro scale within Advantest. It's very interesting.
Yeah.
Okay, so you mentioned the CHIPS Act. The CHIPS Act we have here in the U.S. was about $50 billion that's being used to, you also use the word reshore, but to improve the semiconductor supply chain within the United States. And other countries have similar acts. Now, China has invested well over 10 times that amount, and I think they have plans to invest even more. And of course, there are trade restrictions in place, there are geopolitical issues or challenges that we're dealing with. So can we talk a little bit about what's going on with the various acts and how that's affecting the semiconductor industry, even if it is affecting the industry?
So the government help for me is a little bit blurry, because it's unsure this money really goes into like real fabs and players that really do wafers. So what I'm more concerned with is the capacity that is coming online. So what I monitored is the real position of players today. I think we overblow a little bit China's position. So China today, not many people are well aware of where is China today. Basically, you have 15% of the world's capacity in China. I mentioned earlier the US has 10%. So it is a significant player today, very similar to Japan, let's say, in terms of capacity, not quality, because you will have on mainly older nodes in China and much more advanced in Japan, in the US. Then when you look at what kind of fab you find in China, is only 1/3 will be owned by a Chinese player and serving the Chinese serving Chinese players, because you will find some open foundry also serving some demand abroad, and also you will find the foundries that are owned by foreigners. So in the end, China only owns 5% for themselves. It's not that much, and so far they have to, if they want to grow, they have to spend all this capex. They want to become something like in between 20 to 30% of the world's capacity. So yes, I mean, definitely they will outspend the US, Europe, and Japan, everyone else. They will outspend in order to reach this kind of level, which is not unsimilar to the position of Taiwan, Korea today. Maybe they will pass Japan, maybe. But that's the order of magnitude they want for themselves. So it's a clear path they want to go. I don't want to be alarmist, as some many analysts have gone that way. They have their own weaknesses and strengths, and we have to very calmly analyze what's their strengths, and one of their strengths is the clear path. Then in Europe and in the US, we see also this desire to maintain growth in the capacity, to maintain at least those 10% that I mentioned. So the US will not grow more than the industry. So it will maintain. So maybe some politicians will ask me why I do say that. So, but the industry grows quite quickly. We need to remember this 6 to 7% growth in dollar terms, but in capacity, the order of magnitude is 4 to 5% in terms of wafer output that is added every year. So by 2029, 2030, this is something like a 30% increase in total capacity.
Okay, so I want to ask a question on that. So if I understood correctly, the wafer output capacity grows typically 4 to 5% per year. Did I understand that correctly?
Exactly.
Okay. Exactly. So we have, I don't know the exact number, but close to 30 wafer fab facilities that are under construction right now. And does that track with what the capacity is going to be, let's say in the next 2 to 3 years? And how will that affect the market with so much capacity coming online? Or is it just enough?
So from our findings, so this work we've done at Yole Group, there has been many annonces, and we have to be super careful if those annonces will be fulfilled. Okay, but even if we just look at the annonces, I think we are on the path where we are just fulfilling the Moore's law, or if we just pull the line, this 6 to 7% growth in revenue will come from this 4 to 5% of added capacity per year in the next 5 years. So all the announcers come in line, in fact, with this idea. But we are not told everything. Every fab in China will not communicate super clearly if they are online or not. We try to monitor the key players for sure. This is easy, but then you could find numerous smaller players that are more difficult to track. But overall, what we say is that yes, China will carve a part of the market in the 20 to 30%. That's their goal, but maybe unlikely to go to 30%, but it's always possible. Overcapacity, is there overcapacity today? Yeah, every new capacity that is added will displace some, so supply demand will always equilibrate somehow. And so when we add more capacity ahead of demand, then some people lose. So my opinion about is China adding too much capacity, or overall all the players, are they adding too much capacity? I don't think so far. What's been announced is online. I mean, is not different from what we've seen in the past 20 years. So if we look at, we can locally, maybe in 23 we had some issues for lower nodes in the automotive industrial market. So there will be maybe some price lowering of prices. But overall, what we say is that this capacity addition is similar to what we've seen. The craziness of the Moore law is that it's exponential, and so we will see exponential growth of capacity in the rate of 4 to 5% every year added for the next 5 years.
Okay. That's good news for the semiconductor industry and good for anyone working in that industry. So I'm sure the audience will be glad to hear that message. I want to take that thought a little bit further. So most of the reports, most of the data that I see typically goes to around 2030. And we have this 1 trillion, let's say, goal where the semiconductor industry should reach around 1 trillion around 2030. What comes after that? Have you or has Yole Group looked at what might happen after 2030 and at least have some sort of, let's say, rails on upper and lower expectations?
The question is, what we've seen so far is very why the semiconductor industry, why does it exist? So what are the big underlying trends, the large cycles that it is powering? So in the 80s, 90s, it was typically personal computers. And so it ended up with the internet and then mobile. And so mobile is what powered really the industry in the last 20 years. And now we have a switch towards something else. So even the AI, generative AI is, I think, a pivotal moment where it's not just information. We are going out of the information age, because with generative AI, what can be done is robotics. Basically, if we had to simplify, so you can do typically the autonomous cars that we are dreaming of. Autonomous cars, maybe robots at home, but also industrial robots for sure. So there is the potential. This new technology will require semiconductors. So huge investments today that are in data centers to do this AI compute, and this is our hope that this will be the pulling force for semiconductors in the next 10 years. But I think it will not stop exactly in 2030. I think actually we may need an extra 5 years to reach this $1 trillion. So, but anyhow, I think this has the power to grow the industry, to double. I mean, this is doubling the industry more or less. And for sure, we will still have room for a next cycle, but we still have to discover what kind of cycle will come next.
So we're looking at eventually maybe somewhere between 5 and 10 years, according to Yole, achieving this 1 trillion. But what could be some of the limitations to that growth?
So nobody's really seeing yet, like a structural limit to the Moore's law. So maybe a lot of people saying, okay, we cannot scale anymore, or there are problems to scaling the technology, so we cannot add the number of transistors per square inch the same we could in the past. But okay, eventually. I mean, the Moore's law is still more or less alive, so we improve every year. Okay, but there are, for my opinion, or from our research, we see two issues coming on. First is the capital expenditure or cost. How much do I need to invest every year so that I keep improving in the performance? Can I get the return on investments from this added performance? So this is probably one of the key issue that we have overcome in the last decades, and it's still to be seen if we will. It might require even larger companies than the one that we see today, like the Google, Amazon, Apple, those super large companies able to invest into new generation of chips. And so that is one worry. And the other worry is the energy that the semiconductors consume, or electronics at large. Most of the compute will switch to data centers, and they will require even more and more energy to do this generative AI work. And this is the other issue. So, and it could be a limiting factor. So today, the way the players are mitigating the energy demand or the impact on, for example, I mean, their engagement to fulfill the Paris Agreement, so CO2 emissions, they buy green energy. But at some point, we will not find enough green energy to power the data centers. So that could be another limit to the growth of Gen AI, or it could be an issue at some point.
So do you track the energy consumption of the 10,000 data centers that are around the globe? I mean, where is that right now? Is it 2%, 4%? What is that?
So we need to have a comprehensive picture of the carbon footprint of semiconductor, but I prefer to call it ICT, so all the information and communication industries, because semiconductor is just a small part, and then you have a system and electronic systems. So 50% of this power consumption comes from the internet, and the other 50% comes from your edge, your computer at home or at the office. So it's really the client we call. I mean, some player call it client. So your computer is 50% of the energy demand, and all the back office is another 50%. And so this is typically what we call scope 3. So scope 1 and 2 is to create those computers and servers. We spend energy, and the other, when we use it, this is called scope 3. And again, there is a ratio between what's needed to create, to do those electronic equipment, and the usage, the energy that is required when we use it. And this is also in the order of 50-50. And therefore, when people say, okay, I believe, that the industry has that footprint, we need to ask, okay, are you talking scope 1 and 2, or scope 3, or all together? And in the end, the problem of the industry is the growth, because if we grow so much and we don't reduce the energy consumption, especially for servers, we know it's 50%, especially from usage. This could create, especially from a PR public relation point of view, but probably even more. I mean, if the energy is limited, then we cannot do what we want. So that's probably one direction of improving the technology, to find ways to reduce, to continue to grow. How will the industry? That's the big challenge. How will the industry continue to grow and eventually limit the energy consumption, and eventually could reduce its requirement in terms of oil. So maybe PV is an option. So renewable energy. So I think semiconductor is part of that trend. The transportation revolution to EVs also, semiconductor industry is really helping there. So there is the industry is offsetting a lot of their footprint through helping changing the way we produce energy, or the way we transport ourselves. So I think in the future we will have a lots of debate around what's the real footprint of semiconductors.
Yes, for sure. It's unclear how that will eventually get solved. I mean, obviously we're improving the types of energy that we can create, but like you said, there's scope 1, 2, and 3, and the entire industry and the world keeps growing. And so I would imagine that scope 3 is more of the bigger challenge than scope 1 or 2, because you have the sustainability of the technology. Is that true, or is it? So how does that get divided between scope 1, 2, and 3?
So scope 1 and 2 is what happens in factories. So if you use electricity or you burn something, you know what it is. And as I said, it's quite easy. Usually a computer or server, you know what is the consumption and the lifetime of the server. So you know more or less. For a mobile phone is the same. I mean, you know the number of cycles, and so the energy needed during its lifetime. What I see is the companies are more and more open. Intel, for example, was not so keen a few years back. Now I think they have a very nice view of their footprint. I saw Samsung also is improving gradually every year. TSMC also is trying to go the right way. So they disclose more and more 1 and 2 for sure. But again, with this rule of thumb that once you know 1 and 2, basically scope 3 is you can add another. You double it and you have the whole picture. And I mean, my hope is that the industry will help, changing or will contribute to the way we generate energy, because if we go toward renewable energy, then scope 3 will go down significantly. And so that's probably, this is some of the awareness I would try to convey to the decision makers of the industry, is like the energy generation is green energy generation is super important for the industry, and the more we can contribute to that, the better for the industry.
So I maybe just take a couple of minutes and talk about what you're seeing with 6G.
So again, there is always this demand, or we try to incrementally improve on the previous state. So we've seen this with 6G. If we can increase the bandwidth, typically, or try to again from 5G, we want to increase the frequency. The standard is not yet fully disclosed, so there are several approaches on the table, similarly to 5G, in fact. And so, yeah, there are proposals. Also, I think what we see is space connectivity is, from my point of view, it's probably part of that. How can we include space connectivity with our mobile, I think is a very very attractive proposition, and this will be probably part of 6G.
Yeah, so I do remember when 5G was still being worked on, and it took an extra year or two before it kind of really became an important part of the mobile segment. So I suspect that we'll see something similar with 6G. It does double the bandwidth, like you said. I think it's 320 megahertz, which that has impacts on test, but it's still early days, and I think that we'll eventually see it. It's just a question of what that ramp will be. Do you expect that the ramp will be similar to what we saw with 5G or 4G, or will it be faster?
No, it's not going to be faster. I think as time goes, adoption rates tend to tame a little bit, especially if you don't have a strong use case. We were being asked, I remember, for 5G, what's the use case? Why do we need that much bandwidth? And that's it's still we still need to feel the 5G promise.
Yeah, it's funny because inside of Advantest, we tried to steer away from the motto of build it and they will come. So some companies and some industries embrace that, where if we build it, then they will come. But like you said, for 5G and for other Gs, it was always, what's the use case? Why do I need it? But it always turned out that when it came online, the use cases were found and people found very interesting new ways to use this new capability and new features. So I think it's going to happen with 6G as well. And the same thing happens with AR and VR, and people ask, what's the use case? There's no real use case, but it just takes time for the market to sort of, let's say, get off the ground. So I'm pretty sure we're going to see that. All right, so we're nearing the end of our Advantest Talks Semi podcast. I'd like to thank you, Pierre, for coming on and sharing your valuable insights from Yole Group, and looking forward to perhaps having you back on the show at a future date. So thanks again.
Thank you, Keith, and thank you for having me today. That was a great experience. Thank you very much.
You're very welcome.